DME7 is Yamaha's latest digital mixing engine, designed to be flexible and scalable to help you achieve your creative goals on your next project. In this video, we'll be covering the basics on how to use the ProVisionaire Design software, which is a software that allows you to create your own custom solution, utilizing the DME7 and also a range of other Yamaha devices. This episode focuses on the DME7 device, but you'll also find other videos describing using the software with other hardware offerings. The open architecture of the DME7 gives you many options, and we'll cover some of them here. The video is quite long, but it will be split into a number of short chapters, so you can easily move through to reference each part as needed. So let's jump straight in with the software. Step 1 is downloading and installing the ProVisionaire Design software. This is available from the Yamaha website as a free download for Windows, and I'm going to assume that you've already downloaded and installed the software. When you first open the software, it will prompt you to either open an existing project or start a new project. We'll create a new project here. Then we'll go to the System menu, select Network Setup, and then choose our network connection. Ideally, this would be a connection which is on the same network as your devices, which will then help us in some of the later steps. The software can be used entirely offline if you don't yet have your equipment installed. So our project begins with a blank page. The software starts us on the Project tab. This is where we would assemble all of our devices, and this section can actually display a large number of different devices and will allow us to change visual settings to perhaps group devices together or to denote different parts of a building. You'll see some examples of this later. On this page, there are 4 main sections. The tabs in the center are where the main work will be done. The Project tab I've already mentioned, but there's also the Tuning tab, which is used to configure certain models of amplifier. I'll refer back to the Tuning tab later. On the right, we have a Properties section, which allows us to change the properties of any object that we select. And on the left, we currently have a list of all the possible devices that we can bring into the software. However, because I'm on a network that has a DME connected, I'm going to choose the Network tab here. This will show me all the compatible devices the software can see on the network, and you can see my DME7. Selecting my DME7 allows me to add it into the software. And this will automatically load the device with whichever capacity of license is installed on the hardware. If instead I was to manually add a DME7 to my project, ProVisionaire Design will ask me what type of DME7 license I have. I can create a project using whatever license I want, and this can be changed in the software later. However, when we later come to synchronize to the DME7 device, we'll need to make sure this matches the license on the unit. There are different types of license available depending on your global location. These can have different capacities of Dante I/O and can also have different durations. The process will normally involve a system called ProVisionaire Cloud, which is designed for these license management purposes. It also involves an app which is available for both Android and iOS. This app is called ProVisionaire Portal. The DME7 generates a QR code that's then scanned in the app and verified by the cloud service. Your Yamaha dealer will have more complete instructions available for your region, so it's best to speak with them first. In future, we will try to provide a more complete video description on how to carry out this process. Now we're at the stage where we can start to build our system. On the Project tab, we double-click on the DME7 device, and it will then open in a separate tab. In this tab, you'll notice two sections, Audio and Control. We'll be jumping between these as I explain some of the following items. The Audio tab is of course used to create the audio elements of your open architecture design within the DME7. Control is used to assign control triggers to some of those audio elements, or to send external triggers to other devices, such as contact closures or even remote commands over TCP or UDP. We'll look at this in more detail over the next few minutes. Let's start in the audio section, and we'll begin by choosing the inputs that we need in our system. These will reflect the system schematic that you've most likely drawn for your system prior to starting the software here. So we have a number of types of input. Firstly, we have Dante, which will be selectable up to the maximum capacity you've chosen for your DME device. If you've chosen the wrong capacity, don't worry, you can go back to the project, select the DME7, and you can change the option within the properties section. Just remember that whatever capacity you choose here will have to be reflected by the license loaded on the physical device. Looking at other available inputs, we also have USB. There are 8 channels that come in over the USB-C on the back of the unit, which could be used for recording or streaming purposes. We also have the option of an SD card. On this, we could load files that we wish to play back, and could set triggers for playback within the system. If we want to trigger playback, we select the SD card module, and on the right-hand side of the screen we choose the Parameters tab under Properties. We then tick the option next to Sell and Play, and add a control pin. Then we look on the Control tab, and we'll now see our SD card module. So as an example here, if I added a GPI in, and I make this connection, this would now mean that when we make a contact closure on GPI 1, the SD card could play back a specific file. Double-clicking on the SD card module here will allow us to choose the file that we wish to play back. Note that the SD card must be inserted into your computer to make track selections, after which it can be inserted into the DME7. Currently supported in ProVisionaire Design are a number of specialist components for building your system. These will be expanded over time, but here are some examples. AEC, or Acoustic Echo Cancellation, for use in remote conferencing applications. This process uses a lot of computing power, so it's recommended to limit the size of the module to the minimum size possible, just to allow yourself greater free capacity for other functions. ANC, or Ambient Noise Compensator. This allows the level of your program audio to be adapted based on the level of noise being generated in your space. As more people fill the venue, the system can automatically adjust the output level upwards to keep the sound audible. Dugan Auto Mixing. You may be familiar with Dan Dugan's auto-mixing algorithm. It's very clever technology that Yamaha use in many of our devices now. With Dugan auto-mixing, you are able to gain share between multiple mics, which can be grouped together as required. Save yourself some effort when mixing your next conference by using this feature. Feedback Suppressor. We have 2 different types of feedback suppression, depending on your requirements. Both notch suppression and pitch shift suppression are available. Effects and Dynamics. There are a whole range of options here for compressors, limiters, reverbs, delays, and other functions to help you build your system as required. Also, AGC, Auto Gain Control, is included if you need to include that function. EQ and filters. There are options of graphic or parametric EQs, and a number of useful filters. Speaker processors. By default, with a host of profiles loaded for Yamaha speakers. Room Combiner. This is a very useful resource sharing option within the system. If you have a divisible space, or perhaps have resources that you need to share between multiple spaces, then the Room Combiner will allow you to do this. When you add this component, simply choose the number of zones you wish to use, and then you can bring in your sources, your background music, and even paging. We can trigger the rooms to combine and separate in a number of ways. We just add the relevant control pins onto the module, which I'll show you more details about later in the control section. There are some components that you can add to your design to help you monitor your system, and sometimes to help diagnose issues. The first is the audio detector. This actually can be used in a few ways. The most common will likely be to trigger a threshold if the audio level in a space gets too high. We can set this to provide an output to the control layer by selecting the component, choosing parameters on the right hand side, and then ticking the box next to Detection Indicator. You'll see that every component has a range of different tick boxes that can be selected to bring them onto the control layer. So now, as an example, perhaps if a threshold is met, I want to close a GPI output. I can do this by bringing the GPI out module onto the control layer, and then connecting the pins. It's as simple as that. At the same time, I may have another device that I wish to trigger. I could use something called external events to send a TCP or UDP command to a device. So I bring external events onto this page, choose the protocol, TCP or UDP, and go initially with input number 1. In this case, input refers to a socket connection, so you could have up to 16 different external devices that you're communicating with using different inputs. Double-clicking on the external events module would then allow me to set the IP address and the port of the device that I'm sending the command to, and would allow me to enter the command that I wish to send. So in this case, I'm triggering an RMCG ceiling microphone to mute, just as an example. Going back to monitoring devices, we also have meters, probes, and oscillators. So a meter is a fixed device within your system. You fix it into a position and it allows you to take regular readings from that point. A probe is movable, so you can drop it into different points of your design when it's online, and thus can see any signal that is being passed through. And an oscillator you're likely very familiar with. It generates a tone that you can trace through your system. With the user interface in ProVisionaire Design, there are many ways that you can customize your view or make it easier for you to see elements of your design. Firstly, you can make use of graphics. So I have an example here that I'm using. You can lay out visual elements, group them together, and add custom visuals to make it easier to quickly see different parts of your system. Or in this example, it would be multiple areas of a building. You can change colors and fonts associated with connections and device blocks. You can create custom device blocks that include multiple components, grouping a number of elements of processing together into a smaller space on the screen. When you have many connections crossing over on the screen, you can replace some of these with transmitter and receiver devices, which make the screen much easier to look at. Again, elements can be color-coded to make it easier to identify parts. To link a transmitter and receiver, you just have to make sure they both have the same name. Also, if you make connections in the system, you can trace the connections really easily by enabling the Trace Signal Path feature. This will let you see which routings have been made and can help you understand why you may not be hearing what you might expect. These are just some of the tools available to you within the PV Design user interface, but of course you'll discover more as you spend time with the software. At this stage, it's worth revisiting the Project tab quickly. I've shown you quite a few features of the software so far, but it's easy to overlook the usefulness of the Project tab, which by default will just appear as a grey space with your devices scattered across it. If you've got a number of devices, especially if they relate to each other within the physical system in your building, then the Project tab allows you to use the graphics as mentioned previously and create custom colours and shapes to signify different things. Also here you can visually link certain items like amplifiers and speakers. In particular, if you're using the PCD or XMV series of amplifiers, there's a tab on here especially for you. If you're using multiples of these amplifiers, and if they're all using similar speakers, you may not want to have to configure each of them individually. So as an example here, if I add 2 PCD amplifiers, and I want them to have similar settings, I can right-click on the devices in the Project tab and add to link group. These devices will now appear on the Tuning tab, and by selecting just one device, I can set the output, EQ and gain on multiple units at once. On individual devices, there are different ways of storing settings for recall later. So firstly, we have parameter sets. These relate to whichever device you have selected at that moment, and they allow you to choose which parts of your DSP design you want to store or recall. So, for instance, you could store all of your faders and matrix assignments in a parameter set. Then multiple states of these components can be stored as a snapshot. So I might have multiple snapshots relating to one parameter set, and then I could create other parameter sets and other snapshots as required. Then you can also choose to assign certain snapshots for control panel recall, which will allow an operator to quickly access snapshots using just the front panel menus on the front of the DME7 unit. On the MTX devices, because these are fixed architecture, we have presets on these that store all the settings at once. Then within ProVisionaire Design, we can recall presets or snapshots on multiple devices at once, using something called a linked preset. To create one of these, first set your presets or snapshots on each individual device. We can then go to the Linked Presets button, which is a camera icon, and we can then select the presets that we wish to recall, and we can store these as one entry. Another operation that you're likely to want to do is control your device from an external control system. With the DME7 in particular, because it's open architecture, it allows you to choose which components you wish to control. So you can right-click on a specific component and add to remote control list. This will then give you the option to either assign all parameters, chosen parameters, so for example only a couple of faders rather than the whole bank, or for metering only. This will then mean that you can control or monitor the system using the Yamaha remote control protocol, which is available from our website. The manual includes examples of the protocol, and it's mostly standardized across our devices. We have official support in a number of the large control platforms already, and we're working to increase the support over time to make it as easy as possible for you to integrate our products, no matter which control solution you choose. GPIs can be used to receive direct triggers from other devices, or to trigger external devices. Looking initially at the open architecture devices like the DME7, we can get to our GPI settings by double-clicking on the device to open its design, then clicking on the cog button at the top, and selecting either GPI in or GPI out, depending on what's required. From here, we can assign functions to the GPI port, whether that's a function such as triggering a file to play back from an SD card, or perhaps triggering a snapshot. We may also want to calibrate our GPI ports to allow setting of a threshold. We can do this when the device is online and connected, and we can get to these settings through the System menu and choosing GPI calibration. Once we've configured our GPIs, then we can use them from the Control tab, which I'll explain in more detail shortly. In the same way that we can use GPI, on the DME7 we also have the option of using MIDI for greater compatibility with other legacy applications. On the back of the DME7 there are the standard MIDI in and MIDI out ports. These are configurable in a similar way to the GPI ports, so we can choose MIDI as an option here. Then we can assign snapshots or control parameters to specific MIDI triggers. By this point, I've shown you a couple of small ways in which you can automate within your DSP design. When you're creating your DSP layout, there will be many points at which you may decide to add automations to help your system run more smoothly, or to perform a specific function within your venue. Within the ProVisionaire Design software, you have the power to do this. Many of the audio objects within the builder also have aspects that you can directly control within the UI of PV Design. And as shown before, you can select a specific component and then choose to add a control pin and bring it onto the control page. Once on this page, your device functions either as an input or an output, to trigger or be triggered. Looking through our specific control components, it's perhaps easy to visualize how we may use something like a GPI pin to trigger an output to mute. We ensure that the GPI pins are showing on the control page, and that the output fader has control pins added. We can then simply link them together. In this mode, the fader selection button will mirror the state of the GPI, so if the pins are open, the button will be off, and if bridged, they will be on. If I wanted to reverse the above, I could use an invert function. So this will take whatever you put in and will send out the opposite. Alternatively, maybe we could use an audio detector to trigger a preset when a threshold is reached. We make sure that our audio detector has the control pins added. Then we drag our preset onto the page and just connect the pins. It's as simple as that. Basic control functions like this are of course quite simple to set up, but you can get really very detailed within this control page, using complex logic and triggering multiple functions at once to ensure that your system can react to whatever challenges you may face during your show. This could also include sending commands out to other devices using external events. These can be used to send one-shot or toggle commands out to other devices over TCP or UDP. Control is an internal function of PV Design and it relates to the DME7 device. So, you've created an awesome design, and now you're ready to test it out. You might well be doing this process multiple times during the design and commissioning of your system. Compiling is only necessary for the DME7 and any other supported open architecture processors. It basically combines all the changes you've made into a single file that the system can easily accept. Clicking on the Compile button will open another dialog box, and hopefully this box should say Compile Successful. But if not, then the system can indicate to you as to why the compile may not have completed. Underneath the message at the top, you have a few readings that basically tell you how many resources you've used on your processor. This lets you know if your design is within the capacity of your device. If all is good, just click the Online button at the top. Bring the processor online and it will synchronize your program. Now it will be live on the processor, and you can monitor the different parts of your system in real time from the PV Design software. Now we're on to Chapter 13, the lucky chapter, where we talk about errors. You may have followed me up to this point, but upon compiling you may have seen an error, or perhaps your utilization numbers are more than 100%. This last point is the most common cause of compiling errors. But all is not lost, don't worry. In terms of utilization numbers, there are ways that you can adapt your program to remove some processing overhead. The very first thing will be to look at your modules such as any effects, delays, or objects such as AEC. If these are unused, then just remove them and these figures will reduce. Likewise, if you have spare I/O on some of these objects, reducing the object size will also reduce the overhead. The other thing with the DME7 in particular is of course that you have multiple license types. And these expand not just the capacity, but also the processing power in some cases. You can test out these different sizes of license very quickly by changing your license type in the system and seeing how that affects things. Lastly, there may be cases where you have multiple processors, so perhaps you've exceeded the capacity of one device, but you can utilize some processing from a second device to make up the difference. This is a manual process, but it's still quite possible to share resources with some clever planning. Hopefully these tips have been useful to get you started with your DME7 processor. This video of course only covers the basics, but we will be making some more advanced training available as well for those who want to dive in a bit deeper. For now, if you're looking for tips on using other Yamaha devices with PV Design, including the MTX processors, then check out the other videos in this series.